Hello everyone and welcome to this new Cisco Packet Tracer video. Today we're going to be looking at OSPF, which is a really handy protocol to automate the routing process in your network. So I've written a few steps here. We have to first address the LANs and the router networks. Set the IP addresses. Spoiler alert, this won't be the most interesting part because, it's just IP addressing, but I guess it's somewhat interesting for people that want to follow my exact same topology and be sure it works. So if it doesn't interest you, just skip it to the next part. The next part will be configure really OSPF. So how to really configure the routers so that OSPF works. After this step, we'll have a fully functional topology so that, for example, this PC4 will be able to ping this PC1 without any issue. But we won't be able to get out of this network, so that we'll have to set WLAN access in order to go to the internet, configure the NAT to access the WLAN, and finally define the network's default gateway and spread it through OSPF, so that you just set the default gateway once at the point where it's connected, and the whole network has the information that the default gateway is this particular router. So really convenient protocol because, well, it can help you by saving lots of time and efforts trying to figure out what's the best route, how to set your default gateway on each and every one router so that there's no loop and stuff like that. With OSPF, you just remove all these problematics just as one, and you configure it once, and it's done. Until, of course, you add another router, but even if that happens, you just have to configure the new router and you're ready to go. So as you can see, I've set some notes here so that we can see a bit what's going on. First thing I'm going to do is to configure the LANs. So these kind of endpoint networks where there is a PC connected to it. So this, and this. After that, we'll configure the inner network, and then, well, we'll be over for the first step. So first subnetwork here, 10.10.6.1. Really important to set the default gateway here, otherwise your PC won't be able to communicate with the rest of the network. And of course, the default gateway is just going to be this interface. That was it for the first network. So this time it's going to be the JEG00 interface that will be used as a default gateway. JEG00 IP address 10.10.2.254, and with the mask, and no shut after that. Fine, next network. This one is 10.10.3. And here we can see it's a bit of a mess here with the different labels. So we just move the PC and we can see that it's JEG01 that's moving. So this is the proper router interface we'll have to configure. Just a trick. JEG01 IP address 10.10.3.254 with the mask and no shut. Only 2 LANs left. So this time, once again, it's 0, 1. By convention, I decided that the 254 is going to be the default gateway of the network, and no shut. Last subnetwork. That one, that 254. And by always, 254 will be the router's LAN side address. Well, that was it for the LANs. Now we will have to configure the intermediate networks. So this one, this one, this one, this one, and this one. So here we go. So as a convention here, I'm just gonna use this particular byte. Here it's 6, here it's 2, here it's 1, to define the order and the addressing plan for the interconnection network. So typically here, this router will have the lowest IP address because we have a 1 here, and the highest one will be on this router because there is a 6, and between them we'll have a 2. So this will be the lowest, the medium, and the highest. So let's just configure the lowest IP address. Interface JEG00. IP address. Our network is 10.10.100.0, so it will just be 10.10.100.1, 255, 255, 255, 240, because it's a -28 mask here. No shut. Here it's 01, as we see on the label here. Now it's 2. And finally here, IP address 100.3, 255, 255, 255, 240, and no shut. So this network is operational. Now we will configure this .16 here. So serial 010, IP address 10.10.100.18. 18 because once again 2 is higher than 1, so the 17 is going to be on this router and the 18 is going to be on this router because 18 is higher than 17 and 2 is higher than 1. I'm just doing this in order to keep a coherent address plan, which will be really important for later. It's 252 because we have a -30 mask here. As you can see, even though we just lit on the interface, it is still down for now because, well, the other one isn't lit on yet. So it's not administratively down anymore, it's just down, but it's still down. Now we will enable the other one, and you will see both are going to light on at the same time. Let's just check which port we have to configure. It's serial 011. Yeah, so now our two interfaces are working because they're green here, we can see it. And yeah, the status has been changed to up. Let's just configure the other networks. This one is This time it's serial 010, IP address 10.10.100.21, because once again 1 is lower than 3 and 21 is lower than 22. So we'll have to edit the serial 010 configuration. IP address 10.10.100.22, 255.255.255.252. No shot. So they are up now. Last serial network. This time it will be the serial 011. So interface serial 011, IP address 10.10.100.23. So here it will be 25. And on the other one it will be 26. Let's just check the port. Serial 011, IP address 10.10.100.26, 255.255.255.252. No shot. Fine. Now we just have to configure this network between Amsterdam and Moscova. So jig 00, IP address 10.10.100.29 here, 255.255.255.252. No shot. And on the other one, int jig should be 00, yeah, 00, IP address 10.10.100.30, 255.255.255.252. No shot. So yeah, that was it for the first part. We have addressed the LANs and the routers. Now the next step will be to configure properly the OSPF service, and we will have to do this on each and every one of our routers. So when you configure an OSPF service, you have to do several things. First, you have to declare your OSPF process, and you do that from the configuration mode, and that's pretty simple. You just write router OSPF, and here you just choose a random process number. That's better if you remember it. I'm just going to use 10, and this unique kind of process ID allows you to run multiple instances of OSPF at the same time. For example, if you have this router that is connected to multiple networks, and eventually that uses multiple processes, because you can use IEGRP, RIP, or even IPv6 versions of all these protocols. This ID here will allow you to run multiple instances at the same time on different ports, and that allows you to connect different protocols so that they remain compatible even though they're not the same. So yeah, choose just a router ID here. I'm gonna use 10, but use whatever you like as a number. And now the next step is to define what we call a router ID. This router ID has a kind of IPv4 address format, but actually you don't have to think about masks or anything like that. It's just arbitrary numbers that are used to identify precisely this router on the topology. So it's rather for you in order to understand which router is doing what. And for this particular Madrid router, I'm going to use 6666 because it's the .6 network that it's connected to, so it seems pretty logical to me. So in order to define the router ID, you just have to type router ID with the ID you want to use, obviously. So I'm just going to use 6666. Once this is done, we can really configure OSPF. So in order to do that, you will just declare every network your router is directly connected to. So on this Madrid router, we'll have to declare two networks, which will be 10.10.6.0-24 and 10.10.100.0-28. So let's just go network 10.10.6.0. And here we have to specify not directly the subnet mask, but the so-called wildcard mask. Now, if you don't know what it is, that's pretty simple. You just take a regular mask and you reverse it. Means every bit that was at 1, you set it at 0, and every bit that was at 0, you set it at 1. So in order to represent 255, 255, 255.0, we'll just write 0, 0, 0, and 255. That's it. Now we'll have to configure an area. So I'm not covering the multi-area OSPF routing in this video. Maybe I'll do it later, but for now, let's keep things simple. So just don't ask yourself too much questions and define every network you have in the 0 area, which is also called the backbone area. So just write area 0 after each network declaration, and that will do the trick. You can actually do this in a real environment until you have 15 routers, and beyond 15 routers, using always the same area isn't recommended. You will have to split them up, but for that, it's outside of the topic of this video. So yeah, for now, just use one area that will be the area 0, and everything will be okay. So now we have configured this first network. We'll have to configure this one now. So network 10.10.100.0 and 0, 0, 0. Now it's kind of particular here because it's -28, so just do the binary calculus and you come with a wildcard of 15. So that was it for the Madrid router. Let's just go to London. Router OSPF 10. Now the process ID we're declaring it can be really different on each and every one of your routers. So just don't worry if you here we have 15 and here we have 10. Really, it doesn't change anything, and you can use different ones or identical ones on every router you have. There is no link between them. So router ID. Once again, I'm using this byte to define the router ID, so it will be 2222. Now I will be able to declare my networks. So now on this router, we have to declare 3 networks. This one, this one, this one, and this one. And here, that is pretty interesting. I've been cut in my command because my router is just telling me, hey, I've detected a connection between this router and this router. You can see 6666 is this router ID. So you see the interest of choosing coherent router IDs. The connection, the OSPF connection has been established. So that means our two routers can see each other and can communicate through OSPF to exchange information. Actually, it doesn't really matter. I'm just going to continue my command. So it's -30 mask. So the wildcard is going to be that 3 and area 0. I'm just setting it here in order for you to see the command. And for the next one, it will be just the 10.10.100.24. So let's just go 10 network 10.10.100.24. 0, 0, 0, 255 area 0 as always. So that was it for this router. now it will be this one's turn. So it's kind of always the same thing, you know. Router OSPF 10, router ID, this one is the 1111, network 10 10 1 0 0 0 0 255, area 0. So next, network 10 10 100 at 0 0 0 0 15, area 0. So we should see a connection that will be made here. If we did everything properly, yeah, we can see that this router has been reached, and this one as well. So this router can talk to this router and through this router through this interface, through this network. So that means our connections have been made properly. Now we will connect to this network. Network 10 10 100 at 16 0 0 0 3, area 0. And yeah, once again we reach that router through this network, but it's not through this network anymore, it's through this one, so we're noticed. And our last network will be the 10 10 100.20. So network 10 10 100.20 and 0 0 0 3, area 0. Oops, this goes out of the screen, but you see it's always the same command. Yeah. So our 3 routers here are configured properly. We have just 2 left. I'm just gonna go fast now. I don't want this to be too long, and actually it's always the same thing. So we will see a connection here. Perfect. Here too. Here we will not see any connection because obviously we'll just have a PC connected to it. So don't wait anything here. Last network 10 10 100.28, there 0 0 0 3. Area 0. So our first router has just 2 interfaces connected to it. Yeah, so once again the connection has been made. So now I've just realized that I've forgotten to set the router ID for this Amsterdam router, so I'm just gonna do it real quick. So conft router OSPF 10 router ID 3333. So as we can see here, as I already configured the OSPF process, I just have to clear the OSPF process and start it again. So exit, exit, clear IP OSPF process. Yes. And well, after some time, the OSPF connection are remade, and we can go in show run, yeah, to see the running config, and we can see we didn't break anything, and our configuration are still there, but now we have a router ID that is 3333. So now that we configured OSPF on every router we have on this topology, every PC should be able to ping one another. Now, what I recommend to you, you just go to every router you have, you go enable write mem to save the configuration. You do this on every router. Good thing I don't have too much of them. And once you've done this, you just reload your network. So every probe is going to turn red, and you just fast forward the time, and then only you can test your pings. Because it's happened to me that actually I configured my routers, and then the neighbor relations weren't made nicely, because they made while I was doing the configuration, so they made improperly. So you just reload the whole topology, and then you just test with this tool. And well, the first one are gonna fail obviously, but that's packet stressor, and then we can see the ping probes are passing through, and here we can see after a few unsuccessful tries we can actually ping every PC on this network, can ping every other PC on the network. So that's perfect. That's perfectly what you wanted to do. And as you can see, I didn't configure any static route, neither any default gateway on this router, for example. It's just automatic. It's just finding the way automatically. So enable, you can just show IP route. And what's really interesting here is that we have those those O's here. Those O's on the left, which means we can see here, it means OSPF. These O's here means that the route have been learned dynamically through OSPF. So there is no static routes here. We just have OSPF routes that are created without us having to do anything except it configuring OSPF itself. So it's a real gain of time, and well, hope you liked it. So now we can go to the next part, which will be really interesting, because now imagine you have a connection. This was your corporate network, but now you want to go to the internet, and well, you don't want to enter manually the default gateway on each router of your topology. So what we have to do is to spread the route through OSPF and give WLAN access to the whole topology at once. So first thing first, I'm just going to add a link to the outside network. So this WLAN access will just be symbolized through a router that will be connected to, say, a server with like a switch here, so that it's kind of how it looks like in the wild. And now on this router, we'll have to shut it down, add a 2T interface, and turn it back on. That will allow us to connect to this, Madrid router. Yeah. So I'm gonna address this server. So it will just be the 888. It's just Google's DNS. Default gateway is 888.254. I will just real quick configure the IP addresses here. So now our Google DNS here, I'm just gonna call it Google, is connected to his router. So I'm just going to draw a zone here that will be representing the internet. So our network's private IPs just stop here. Our public IP is there, and we will define it right now. Write a note here. That will be 200.001-30. And this is our public IP. So obviously this router will have 200.0.0.2-30. But the idea being that our private network in 10.10.stuff stops here. So to communicate on this network, we'll have to translate our private IP addresses to public IP addresses that the network will understand. So first I'm going to restart my router because I stopped it the other time. Yeah. And configure the IP address. Int serial 010, IP address 200.0.0.1, 255.255.255.252, no shut. And I'm going to do the same on the Ethernet network. No shut. Now that we've done the IP configuration, we will just do the NAT configuration. So now I'm just gonna configure the NAT. So in order to do this, I'll have to configure first an ACL because, well, the ACL will be used to identify which traffic we will want to NAT. So for that, I'm going to use a standard access list. So IP access list standard, and I will call it, NAT. And now I will just declare some rules. So permit 10.10.6.0 with the wildcard mask once again 0.0.0.255. The same with 1, same with 2, same with 3, 4, and 5. So our LANs are correctly targeted. Now we have this permit 10.10.100.0.0.0.15, permit 10.10.100.20.0.0.0.3, permit 10.10.100.24.0.0.0.3, and is that it? Nope. Permit 10.10.100.16.0.0.0.3 and permit 10.10.128.0.0.0.3. So this access list is important. You just declare every network you have, and then you will be able to translate the private IPs in public IPs. Once this access list is configured, I will be able to configure the NAT. So I'm just going to write IP NAT inside source list NAT, because here is how I named my standard ACL here. So now that my access list is ready, I will configure the proper NAT. So the first step is to define which IP addresses we will be using to forward the packets we receive. For that, we will declare an IP address pool, but actually, as we only have one IP address here, that is 200.0.0.1, we will just declare a pool that will contain only one public IP address. So I'm just going to say IP NAT pool. Here I have to give a name to this pool. So it will be public IP. And here we asked to specify the start IP address, and that's pretty easy because we only have one, so 200.0.0.1. And actually the end IP address is the same, so 200.0.0.1. Now we have to specify the net mask, and it will be 255.255.255.252. Can enter this command, and now we will have to configure the proper NAT. So I'll have to make correspond the NAT pool I just created with the ACL I done before. So I'm just going to write IP NAT inside source list, and then I have to write my access list name, which is NAT, and pool. And here I write my newly created pool. So I've named it public IP. Here I have to precise that I use the overload NAT mode. This isn't really the topic of this video, so if you're really interested to know how the NAT works, just do your research. But for now, I won't spend time on it, so I'm just gonna hit enter. Well, this isn't over yet because I still didn't say which interfaces will be inside and outside of the private pool. So I'm going to configure this serial 010 to tell it's outside, and serial 010 IP NAT outside. And the other ones, so the gigabit ones, will be inside. So int gig01 IP NAT inside. Same for gigabit 00 IP NAT inside. So now, from now on, our NAT is ready, but what's left to do is to define the default gateway. This step is over. Now we have to define the network's default gateway and spread it through OSPF. So how we will do it? Well, it's pretty simple. Now, what's really important is to declare this network in OSPF, because if you don't, you will be able to say that this router is the default gateway, but they won't be able to access it. So it's really important that you just declare this network so that the entire OSPF topology is aware that this router exists. So to do that, you just go back to the OSPF config, exit, router OSPF 10, network 200.0.0.0, and the mask is 0003. Just set it in area 0 as always. And actually, you don't need to do the same here. Although you need to give it a proper name, so I'm just going to call it, well, New York. So now I'm just going to take this PC and try to ping this default gateway. So ping 200.0.0 and 2. And here we have a response. And what will be interesting to do is to go into simulation mode and to try that again. So ping. We will follow the packet here. It goes through a regular route. And now we're going to look at it. So we have the in layer here, which is 10.10.11. That's perfect. And that's exactly what we wanted, because this is the PC's IP address, 10.10.11. That comes from this network. So obviously this is the source IP address. And the destination IP address is obviously the one we set in the ping. Although, as we applied NAT on this particular router, when it comes to the out layers, we can see that the source IP address has been translated. It's 200.0.0.1 now. It's not 10.10.11, which is the private IP. It's 200.0.0.1, so that the packet is NATed properly. It's properly translated to a valid public routable IP address, so that this router will be able to respond back to this ping. So we just can forward it. Yeah, this router receives it, okay, and send it back. And that will be the same process, because the source IP address is 200.0.0.2, the destination IP is 200.0.0.1. But now, as we have set the NAT here, that's pretty cool. The IP address is translated back to the PC's IP address, so that the packet can find his way back to the sender. So that's pretty cool. And this packet, you will see, can find his way back all the way to the PC. And yeah, the ping has done his way through. So that's really what we wanted to do. So this is a pretty cool part. We have a NAT that's properly configured. We can access this router, which will be used as a default gateway. But now we have one last thing to do, and that's because if you try to do the same to reach this Google server, you will not be as successful as we were before, because actually here we have a host unreachable message, because this router doesn't know what's behind this this router. We can ping this one, but we can't go beyond. We can ping the Google server. So what we need to do next is to simply define a default gateway to this router, so that it understands that if he doesn't know the destination's IP, he has to transmit it to this router, and he'll take care of the rest. So in order to do that, I'm just going to declare a default route here. So conft IP route, and then I'm just going to set the destination prefix. And to set a default route, I'll just write 0000, and then I'm asked for a destination prefix mask, and I'll write 0000 again. So this match corresponds to any IP that could be outside of this network. now I'll have to define the next hop. So I'll just use his IP address, which is 200.0.0.2. And well, the other parameters are optional, so I'll just leave it as is. Now, if I try that ping test again, I'll have a few crashes first. But hey, now we can see it's successful now. Because now this router doesn't have the knowledge this server exists, but it has the knowledge that this router is the way through he can reach unknown IP addresses. So he doesn't know 8888 exists, but he knows that this router knows it. So this router just sends every packet he doesn't know to this one, and this one finds his way to 8888. That's what we wanted to do. So that's cool. This PC can ping this one, but what we will see is that this one won't be able to ping the server. And that's because, fairly simply, this router, which is this PC's default gateway, has no idea that the rest of the internet can be reached through this router. Madrid knows, but Paris doesn't. So what we'll need to do next is to inform the whole OSPF area that Madrid is the router in charge of transmitting packets all over the internet. So I'm just going to go back to my router OSPF 10 process and write a pretty simple and straightforward command that will do exactly what we need, which is default information originate. Enter. And that way, now, this router is going to just say to his friends here, I have a default gateway to go to the internet. So if you have any packets that you're in trouble with and you don't know where to send them, just hand them over to me, and actually hand them over to New York. That will take care of all the dirty business. So the information is just going to spread through the area, and we just fast forward the time a little bit. And for example, if we go on Moscova, we can display all the existing routes. So show IP route. And here, that is really interesting. We have this O times E2 route that has been learned actually through OSPF as before. But do we have an entry for that? E2, yeah, OSPF external type 2. That means that we have this network, which is basically the default network, all the networks we don't know, that can be reached through 10.10.100.29, which is basically this one. And if we go back to this and to this and to this, we will see that every finger points in that direction. We can do the same here, show IP route, and here we have the same route, OE2.0.0.0. So every network we don't know on our routing table can be reached through this 10.10.100.3. I remind you that's this IP address we can see there, and this router is going to take care of sending every unknown packet to this one. So we can now test our final ping, which will be go from this PC to Google, ping 8888, and here we have a reply. So that means our route has been properly distributed through the whole infrastructure, and all these routers know that if they have an unknown IP address, they have to hand it to this router. So that's the end of the list I had established for today. I hope this wasn't too long, but as you may have noticed, there was plenty of things to do. Hopefully now you understand a bit better how OSPF works and how to configure it in order to automate your routing process. Anyway, that's all I have for you today, guys. Hope you enjoyed this video as much as I did. So, well, like, subscribe, and usual stuff, and see you next time for the next topic.